Assalamualaikum and hi. First and foremost, I would like to introduce myself as the leader of the project code P01S21. My name is Nurin Hanani binti Halim and the other two group members are Intan Nur Shakina binti Mahari and Nurul Natasha binti Shafi'i. Welcome to our presentation. We are going to present our FYP, which is Extremal Properties of a New Generalized Class of Tilted Analytic Univalent Function. This is our presentation outline. Let me start with the abstract of our research. So our research is involved geometric function theory, which is a branch of complex analysis that aims to study the geometric properties. The problems that we discovered throughout our research is that it involved many definitions and theorems, and there are only a few methods that can be used to solve the problems. The aim of our research is to define a new generalized class of tilted analytic function, class of M, in terms of beta and delta, and also to determine the new representation theorem of a new generalized class of M. We applied the method of Herglot's representative theorem and we obtained a class of function g of z and also center and radius. The origins can be traced back to 1851 when Riemann proposed the well-known mapping theorem in his PhD thesis. Bieberbach's research was posed in 1916 concerning the size of the moduli of the Taylor coefficients of this function. The researcher studied on analytic univalent function where it became the focus of his intense research. Harmonic univalent mapping, which are widely known to have a wide range of applications, are closely related. They appear in the modeling of many physical problems, including the study of fluid dynamics and elasticity problems. The importance of stating definitions derive from the fact that all functions and definitions serve as foundational information for the researchers to begin the research. Problems that we discovered throughout our research is that there are many class of functions, but it is difficult for us to introduce a new class of function because it needs to satisfy all definitions. This is quite time consuming. The next problem is that it is difficult for us to determine suitable method that can we apply in our research. This is because some methods are unable for us to find the properties, and it need long equation and also need many techniques. There are three objectives that we are looking for. Firstly is to introduce new generalized class of tilted analytic function M. Next is to determine the new representation theorem for a new generalized class of M by using Herglot's representative theorem, and lastly to find the coefficient bound, center and radius of M. The research of this study focuses on obtaining new representation theorem of class of function, and the representation theorem will produce a new theorem such as coefficient bound, center, radius and distortion theorem. This study will offer a new idea that can be developed in the field of geometry and also provide a new knowledge to the researchers for guidance. Besides mathematical learning, they can develop problem solving skills and also reading comprehension throughout this research. Limitations that we have gone through is lack of knowledge. We are having difficulty doing some reading and searching for sources of information because this is a new study and only few others that have discovered this study. Next, it involves many definitions and theorems. Every term used in this research needs the reading of numerous research papers in order to familiarize the terms used in this research and to comprehend the functions and terminology that we rarely use and are unfamiliar with. Lastly, analytical proving is the main writing of this research. Analytical proving requires extra caution because the method is time-consuming compared to using software. For literature review, the coefficient bound for star-like function was established by Srivastava et al. In 2011. Below is the coefficient bound obtained. The coefficient bound for a general class of spiral-like function was established by Zhu et al. In 2013. Below is the coefficient bound that they obtained.
Okay, so next, based on Akbarari et al. 2011, The outcome of the coefficient bound is this. And then, based on Muhammad 2001, the coefficient bound result is this. Last but not least, based on Radi et al. 2018, the coefficient bound is this. So, in summary, there are many researchers found extremal properties by using Hilbert representation theorem. The Hilbert representation theorem's approach is used in this research as it is the simplest and easiest method compared to other methods. Other than that, Hilbert representation theorem also is an accurate result that determines the extremal properties. Next, we move on to methodology. Certain class of closed-to convert univalent function is difficult to discover an acceptable way to tackle the problem, so that only a few researchers are interested in this subject. The Hilbert representation theorem, published by Hilbert in 1911 to identify the extremal properties of the class of function, will be implemented in this project. Okay, so next is the methodology step. So the methodology step consists of 9 steps. First one, we define new generalized class of functions. The class denoted as m beta delta. And then, Taylor series will be applied for certain functions. Next, the function will be related to the class of function with positive real part p as the basic method to find new representation theorem. Next, in order to obtain new representation theorem, we apply Hilbert representation theorem, and then we will normalize the function by make sure f0 is equal to 0 and f prime 0 is equal to 1. And then we will use a different method like Maclaurin series for certain function. And next, we replace step 4 of the representation theorem with the function obtained in step 7. And then in step 8 and 9, we obtain the coefficient bound and center and radius of the function.
Result and discussion. In this project, we generate new theorem. First theorem is theorem 4.2.1, which is it shown that the function in P is related to this equation. Second, theorem 4.2.2, by letting f element of class M, f can be represented as this equation. Third is corollary 4.2.3. This corollary shows that our class is normalized. Next is lemma 4.3.1. By letting function of x null equal to 1 over 1 minus x null resulting into that summation. Then theorem 4.3.3. Suppose that function element of class M and the coefficient bound is obtained as shown. Then proceed to theorem 4.4.1. If function element of class M, then the f prime maps into the disk D with that center and radius. We proceed to corollary 4.4.2. The simple geometry of a circle enables us to deduce from theorem 4.4.1 and get this equation. Then theorem 4.4.3 states that if f element of class M, then the bound of the function is accurate for any extreme point of function element of class M. We move on to theorem 4.4.4, which states that the bound of real part of f prime are sharp for any extreme point f of class of M. Last theorem is theorem 4.4.5. This theorem states that the bound of imaginary part are sharp for any extreme points f of class of M. For validation of result, the function of M are normalized since f of 0 equal to 0 and f prime of 0 is equal to 1. Then the final result is unable to reduce to another result because this function is a new class. Conclusion. The main aims of this project is to determine specific extremal properties such as representation theorem, coefficient bound, and center and radius. Hilbert's representative theorem is used to find representation theorem for the new generalized class. The objective of this project has been successfully complete. Lastly, recommendation. We have several recommendations for other researchers. Firstly, we would like to recommend for other researchers to study on the same class of function, but by applying another method, such as new differential operator. Besides, we would like to suggest other researchers to find another extremal properties using the same class of function. This is our reference that we use for this slide. That's all from us. Thank you.